Where the sea meets the sky, when every other layer of defense has fallen silent, one system still stands. This is the Phalanx, the U.S. Navy's close-in weapon system. The final safeguard that unleashes thousands of rounds per minute to eliminate threats that breach the perimeter. A CIWS, or close-in weapon system, is a point defense weapon designed to protect ships at extremely short range. It detects, tracks, and, when required, automatically engages incoming anti-ship missiles, aircraft, and fast surface craft. The most iconic example is the Phalanx, an autonomous turret built around a 20mm Gatling gun and equipped with its own radar suite. The story begins in the 1970s. As high-speed anti-ship missiles became more prevalent, the U.S. Navy needed a defensive system capable of reacting instantly, faster than any human operator could. The answer was the Mk-15 Phalanx, tested in the late 1970s and deployed in the early 1980s. From that point forward, it has continually evolved, upgraded power systems, improved electro-optical sensors, enhanced stabilization, and even missile-armed derivatives such as SeaRAM.
Stop! So this is gonna happen every once in a while. We're gonna have things that are... Alright, ready? Ready? Go! Ready? Go! Stop! At the core of the classic Phalanx configuration lies the M61 Gatling gun, a 6-barrel, 20mm cannon capable of firing several thousand rounds per minute. Surrounding the weapon is an integrated architecture of systems. A dedicated search and tracking radar. An automated fire control computer that evaluates threats and authorizes engagement. A drum magazine supplying ammunition, and, in modern variants, a stabilized turret fitted with electro-optical and FLIR sensors for visual tracking. Together, these components operate within fractions of a second, detection, classification, tracking, engagement, and instant assessment. To put its performance in perspective, recent versions can fire up to approximately 4,500 rounds per minute. Projectile velocity exceeds 1,000 meters per second, and ammunition capacity typically reaches several thousand rounds depending on configuration. The objective is clear: to shred or destabilize the incoming missile's airframe before it can strike the ship.
The Phalanx has advanced significantly over time. The Block 1B variant incorporates a stabilized electro-optical sensor suite, allowing precise visual identification and tracking, particularly useful against helicopters, fast attack craft, and targets hidden within complex environments. A major leap forward came with SeaRAM, which merges Phalanx sensors and software with an 11-cell rolling airframe missile launcher, delivering a missile-based close-in defense option within the same platform footprint. In real combat scenarios, the CIWS can function in fully automatic mode, surveying its arc, acquiring threats, and opening fire the instant engagement criteria are met. Operators may supervise the process, authorizing or halting engagements as required. This level of automation compresses reaction time at the moment outer defensive layers have already been breached. The system has seen real-world use, sometimes with decisive results, other times highlighting the complexity of modern warfare. It has been employed in multiple conflicts and naval incidents as a last-ditch shield. But it is not without limitations. Weather, sea spray, smoke, decoys, and saturation attacks can degrade performance. And by design, it operates at short range. If earlier layers of defense neutralize the threat, the Phalanx may never fire at all. The concept has also been adapted for land-based protection. The SeaRAM, or Centurion system, employs similar technology to defend bases against rockets, artillery, and mortar fire. The philosophy remains unchanged, an automated, ultra-fast protective layer designed to respond within moments. Critics note its limits against mass salvos or low observable threats, as well as the cost and complexity of maintaining the system within broader defensive networks. Future upgrades aim to address these challenges through improved sensors, programmable ammunition, advanced tracking algorithms, and tighter integration of combined gun and missile solutions. The Phalanx is not a miracle weapon. It represents the final boundary, the line where a ship's survival meets the edge of chaos. When every other layer has failed, only a torrent of tungsten and a spinning turret remain, until the threat is gone.
3, 2, 1, mark.